about your foundation. And most of the questions that you find it very difficult to do in acid, base, and salt is likely going to do with this table. So we're going to build upon this knowledge. We're going to stretch it further. Let's take a look at the next page. Preparation of salt. Now, preparation of salt, this is the final part actually. So the preparation of salt, we are classified into two different categories. One is soluble, one is insoluble. Now let's talk about these three different techniques first. For the soluble salt, we have used titrations or filtration. Now, filtration these days, they don't really call it filtration anymore. They call it as add in excess method. Okay, they're more often they call it add in excess method these days. Insoluble, which is precipitation method. Sometimes these days they don't call it precipitation, they call it as ionic precipitation. So you might be familiar with this term. So ionic precipitation or add in excess method. Now let's take a look at the picture. What is the meaning of titration? What's the meaning of add in excess? What's the meaning of ionic precipitation? It's on your next page. So we see the picture first. Titration, what does it mean? That means you simply add an alkaline, which is an aqueous solution, to an acid, which is an aqueous solution. Now, do you notice that both acid and alkaline are solution? They are soluble in water. At the end of the day, your salt, because acid and alkaline give you a salt. The salt is what? The salt is also soluble in solution. So which means that if you want to do a titration process, the first rule is the salt must be soluble. The starting material must have an acid and alkaline. You must have acid and alkaline, and both of them are soluble. So that's why I classify this as soluble plus soluble to give you soluble salt, because it's a soluble acid plus a soluble alkaline to give you a soluble salt. So it's a triple S. Now, let's take a look at a second version of preparation of salt. We're looking at the big picture right now. Let's take a look at the second version. Second version is what we call add in excess method. Now, what is the add in excess method here? Well, we take a look at the picture. Picture is easier to see. So one classical example is copper 2 oxide. Now, you must be able to know right now whether it is soluble or insoluble in water. Because oxide, who are the soluble one? If you remember the table using the memory technique, we call it SPC. Only SPC is soluble. Copper is not in the soluble trend. So this is insoluble. And the acid is soluble. Can you see that? So in other words, you want to do any excess method is using an insoluble salt added into a soluble salt. Most of the time it's an acid. So you add in excess. What is the purpose of this reaction? To make sure all the acid fully reacted. Therefore, then you collect the salt, and the salt is soluble. So to summarize this, we are using an insoluble salt combined together with a soluble salt to give you a soluble salt. So you take a look at the top of the table. I give you a summary on top. We say that this is soluble plus insoluble to give you soluble. Okay, so it's soluble plus insoluble to give you soluble salt. That is the second method, which is the preparation of salt. Let's take a look at the third method. The third method is focusing on preparation of insoluble salt. We're looking at a big picture right now. Preparation of insoluble salt, we take a look at the pictures here. So you must know your solubility table at the tip of your fingers. We know that AgNO3, no nitrate, everything is soluble, everything is soluble. NaCl and HCl, they are soluble. So this is like soluble plus soluble together give you insoluble salt. So soluble to give you insoluble salt. And that's why if you take a look at the summary table, soluble plus soluble to give you insoluble salt. This is how you do it. Now, let me just go back right to the summary table again. Now, once you get some idea, like for example, how to prepare a salt, which is the three different methods, titration is using what? Soluble plus soluble to give you insoluble. So I represent insoluble. Then how about method number? No, not so insoluble, sorry, soluble. My bad, soluble. Soluble, but soluble to give you soluble. Filtrations is soluble plus insoluble to give you soluble. Right? Remember this. How about insoluble? Insoluble will be soluble plus soluble to give you insoluble. That's the gist of it. Now let's take a look at the practical aspect. Like for example, what kind of question would they throw you to let you decide which method you need to use? So you really need to decide one. So for example, I have a salt here. That is NaCl. Let's begin with something basic. Now they won't tell you, say that, hey, NaCl is soluble in water. Okay, they won't tell you that. You have to decide for yourself. So based on the solubility table that you have memorized, which just on the memory technique, you should know NaCl is aqueous. Now, being aqueous, that means it's soluble salt. So whenever you see a soluble salt is formed in the process, you will always look at this one. Now, the question is, which method do I choose? Do I choose a titration or do I choose the NASS? So the rule is like that. Whenever you have a soluble salt, you will always choose titration first. If titration fail, then you go NASS. Got the idea? So that means if you have a soluble salt, you always choose titration first. Titration fail, then you go NASS. Later I'll show you how you troubleshoot it. If you have an insoluble salt, then it's straightforward. Precipitation method immediately. Now let's come back to here. Okay, so I know this is the aqueous, all right? I want to choose a titration method because based according to the strategy. So how am I supposed to do it? Now, this strategy I'm going to show you here will work 99.9%, maybe 100%. Okay, you shouldn't fail. So let me show you.